Hello everyone. In this video we're going to review vector addition by components, one of the essential skills in physics. We first encounter this usually in kinematics, but we can use it in a variety of areas, forces, torques, and then in physics 2 we'll see it for working with Coulomb's law, working with magnetic fields, etc. So let's dive right in. So in this problem, we have a cruise ship, which is traveling east for 620 kilometers. It will then change course and travel for 440 kilometers at a direction of 45 degrees southeast. It will then change course again and travel 53 degrees southwest for another 550 kilometers. What is the ship's displacement, including direction, from its original position? Now, the first thing that I'm going to do is I am going to want to draw a picture representing my motion. So I'm going to want to put a little bit of a grid up. Okay, so I'm going to start here, and I am going to use different colors to represent my different motions. So my first part of the ship's motion is for 620 kilometers, which I've represented here, and it is just due east. Okay, so I made a straight line. My ship is then going to turn and go to the southeast. So I'm staying in the east, but now I'm going south as well, which is going to be below where I drew. And I'm going to estimate this. Okay, so this angle is 45 degrees, and this is 440 kilometers. Again, estimating. Finally, I am going to go to the southwest. West meaning I'm going to be going backwards. South, I'm going to still be going down. And that's about 53 degrees, so I'm going to have to make another estimate. So like so. Made it a little longer than the previous line. And that is 53 degrees. So I'm going to end up right about there. And if I were to want to go back home, that's the line that I would follow. Okay. And I can mark what that major angle would be. Okay. So now that we've done that, I don't need my grid anymore, so I'm going to turn it off. So what I want to do to solve this and figure out what this resultant is I want to make a little chart for myself. Okay, so vector 1 only went in the x direction. Okay, only traveled to the east, which is what my positive x direction is. And my y direction is going to be the positive south. So this traveled 620 kilometers. Okay. Now I do want to mention something about me saying positive south. Because I don't go north anywhere on my diagram, I'm going to treat south as my positive direction. However, normally you would have south as being negative. Okay. So that's vector 1, just going to the east. Now, vector 2. Vector 2 travels in two directions. It travels to the east, it travels to the south. So what I want to do is I want to draw in the legs of essentially that right triangle. and have an X direction and a Y direction. And I'm going to use trig to find those two. I'm going to say X is equal to 440 kilometers, my resultant, times one of the trig functions of 45 degrees. Specifically, I'm going to use the cosine function because that 45 degrees touches the x side of my triangle. And I'm going to hit that into my calculator. 440 cosine 45, and that gives me 311 kilometers. So when my ship was making that leg of the journey, it essentially was traveling 311 kilometers 311 kilometers to the east. I'm then going to do the same for the y direction. But if you remember correctly, at 45 degrees, your two legs are the same length. So that's going to save me a little bit of time. So I know now my x is 311, my y is 311. So far my ship has traveled, well, let's see, this would be 931 kilometers to the east of where it started, and 311 kilometers to the south of where it started. Now let's deal with the third leg of our journey. I'm going to do exactly the same thing. Draw in my two legs, x and y. X, again, is going to be my length times the cosine of 53. Cosine again because it's touching that x side. So 550 cosine 53 is 331. Now you know where I've been getting that 331. And my y is 439. Oh. Y would be using the sine side. And now I'm going to put them in my table. But what I have to remember is my x went in the opposite direction. So it is negative. But my y, we did still go to the south, so I'm going to treat that as positive. Okay. Now I am going to add these up. 620 plus 311 minus 331. I hit that in and I get 600. 311 plus 439. I hit that in and I get 750. So what this means is that at the end, my ship is south of its original point by 750 kilometers and east of its original point by 600. So what that looks like is this: 750 to the south and 600 to the east. This angle and that angle are the same. We now want to find what that resultant is. So to find that resultant, I'm going to use the Pythagorean theorem. My resultant will be the square root of my x squared plus my y squared. So if I hit that into my calculator, and I take this root, I get 960 kilometers. That is how far my ship is from its original position. Not the distance that it traveled, but its displacement. So if my ship wanted to turn around and go home, that's how far it would have to travel. But my question also asks me to include direction. To include the direction, I'm going to have to use trig. Okay, so this angle, which as we said is the same as that angle, I am going to say, all right, I can use any of my trig functions, but I'm going to use the tan function here in case I made a mistake finding that resultant. I'm going to say that tan of that angle is equal to my y side divided by my x side, or my angle is the arctangent of 750 divided by 600 and that gives me 51.3 degrees. And as we can see, we again are south of east. Okay. Well, I hope this was helpful, and perhaps I'll see you in another video.